Hi, Jack. So this is the one I was getting tripped up on yesterday. So you're looking for delta G here. You have a base that's dissociating. Remember that keyword in water. You have the KB. So I thought it was going to be that easy because here's what and all of these pieces of information are going to help you find that. So pause it now and see if you can get there. And then if you can't, restart the video and I'll go over the solution. I was thinking of this relationship, but I missed something very important. That's at standard conditions, and you're not looking for delta G at standard conditions. Therefore, you're going to use a different equation, the one below it. Okay, here's where you can calculate delta G at non-standard conditions. So you're still going to, remember you took the negative RT LNK, you did do that yesterday. That part still goes right here, but then you have to add a correction factor in order to get to the delta G at non-standard conditions. So you need to know what Q is. Okay, so first thing you have to do, which you did the other night, I forget if you got this answer, but is just find the delta G at standard conditions. So just pause if you need to see that work. Next thing you're going to do is find Q so you can plug it in. Remember, Q is just like K. It just may not be at equilibrium. You'll know it's at equilibrium if your value for Q equals K, and it doesn't, so it's not at equilibrium. The only thing that's a little tricky here is that you're not just given your hydroxide ion concentration, you have to go through pH to get it. So, I mean, this is like a 17-step problem, which is a lot for a multiple choice problem. But that's just my opinion. Okay, so once you have Q, you now have all your parts. So plug in all your values, and then I got really close to the first answer, A. Hopefully that's correct and I didn't make any math errors, but you're going to check me on that. Okay, hope this helps. Bye.